For this question, we want to find the derivative of the equation y equals secant of 4x minus 2 plus e to the 7 minus x plus natural log of x squared minus 1. As I look at this equation, what I notice is these plus signs separate into 3 terms. And one of the derivative properties is that you can calculate the derivative of the terms individually. So I'm going to start by calculating the derivative of secant of 4x minus 2. And we'll start with the derivative of secant, the outside function, which is secant tangent. And we're going to leave the inside function the same. But because the inside function of 4x minus 2 is something other than x, we need to chain by multiplying by the derivative of the inside. So the derivative of 4x minus 2 is 4. So if I clean that up a little bit, that's the derivative of just that term is 4 secant of 4x minus 2 tangent of 4x minus 2. So then I'll move on to the next term, which is e to the 7 minus x. And I'm going to start with calculating the derivative of the outside function, which is my e, or e to the x. We know the derivative of e to the x is e to the x. And the inside function is 7 minus x. So because that's something other than x, I need to chain by multiplying by the derivative of the inside. I also need to keep that inside the same. So the derivative of 7 minus x is negative 1. And then on this final term, the outside function is natural log, so I need to follow the rule for natural log. The derivative of natural log x is 1 over x, or in general, u prime over u, that's the inside derivative over the inside. So we're going to get the derivative of the inside of x squared minus 1 is 2x over the inside of x squared minus 1. So we've got here a change to minus instead of plus. And I'm just carrying that last term down. So we have the derivative of y is 4 secant 4x minus 2 tangent of 4x minus 2 minus e to the 7 minus x plus 2x over x squared minus 1. On this question, we're going to use some calculus techniques to answer the question. On this question, it says which point on the graph of y equals square root of x is closest to the point 7, 0. So just to get an idea of what's going on, I'm going to sketch a picture of the graph. Y equals square root x is the top half of a sideways parabola. And then we have the ordered pair 7, 0. So we want to know what point on this curve is closest to the point 7, 0. So when we're talking about closest, we're talking about the distance between the points. So we want to find the distance between 7, 0 and some point. I'm going to guess it's right here, but we don't know what that ordered pair is right now. It could be any point that is on that curve. So it's some xy. Now we do have a formula for distance. between 2 points, and that is the square root of x2 minus x1 squared plus y2 minus y1 squared. So I want to substitute into this formula the 2 points that I have written here. But before I do that, this ordered pair is not any arbitrary ordered pair. Using xy assumes that it could be any point anywhere on the plane. We're specifically saying that it's on this curve. So the points that are on this curve will follow the pattern of this equation. So I'm going to replace the y with square root of x because the ordered pair must be on that curve. So now I'm finding the distance between the point 7, 0 and any point that is on the curve square root of x. So let's see what that looks like. We have the square root, and I'll assign this one to be x1, y1, this one to be x2, y2. We have x2 being x minus x1, 7 squared, plus y2 square root x minus y1, 0 squared. And we'll do some simplifying here. That's the square root of x squared minus 14x plus 49. And square root of x squared would be just x. I skipped a few algebra steps there. And I can combine these terms together to get these two like terms to get negative 13x plus 49. Okay, so now I have a formula which represents the distance between the point 7, 0 and any point on the curve square root of x. And my goal is to find the closest point, and that's where my calculus is going to come in. So to find the closest point, I want to have the smallest distance, and that would be to find my relative minimum for this. So I'm going to use, I'm going to use my distance formula. D equals square root of x squared minus 13x plus 49. I'll rewrite it so it's a little bit easier to calculate the derivative. I'm going to calculate the derivative and find the critical numbers. So the derivative of x squared minus 13x plus 49 to the 1/2 power would be 1/2 x squared minus 13x plus 49 to the negative 1/2. We're going to chain by multiplying by the derivative of the inside. So that's 2x minus 13. When we simplify this, we have 2x minus 13 over 2 square root of x squared minus 13x plus 49. So I've calculated the derivative and I need the critical numbers. The critical numbers are where the derivative is equal to 0 or the derivative is undefined. So if I set the numerator equal to 0, that's going to give me where the derivative is equal to 0. So x equals 13 over 2 is one critical number. 13 over 2, just a little bit less than 7. We've got 6.5 for one critical number. And then we're going to look and see where the derivative is undefined. And that would be where this denominator is equal to 0. I'm going to use the quadratic formula to solve this. X equals negative 13 plus or minus the square root of negative 13 squared minus 4 times A times C all over 2A of 13 plus or minus the square root negative 13 squared, that 143. No, I don't think so. 13 times 13, 169. Minus 4 times 49. That's 196. And you can see that we're getting a negative underneath our radical. And so that means we have imaginary solutions and we don't gain any critical numbers from this, from having the derivative be undefined. So we have only the critical number of 6.5. Let me just wrap this up here. So this is negative 27. So this is not a real number. And we have no critical number from this calculation. So we have our critical number of negative 6.5, and I want to determine if this is a minimum, because remember we're trying to find the point that's the closest. So I want to take on my chart 6.5 and I want to test the numbers around it. So let's test 6 and 7 into the derivative. We can do that with a calculator. We have the derivative equaling 2x minus 13 over 2 square root of x squared minus 13x plus 49. Let's type that into the calculator to see what sign we get. Okay, so we have the calculator, and I'm going to type in to the y equals menu the function 2x minus 13 over, and I need parentheses for the whole denominator, 2 times the square root of x squared minus 13x plus 49. And let me close parentheses for that denominator. So let's look at it on the graph. Looks like I've got my window a little bit crazy there, so I'll hit zoom 6 for standard. And I'm going to do second, hit the trace, which brings up the calc menu. Select number 1, that's value. And I'm going to put in a value of 6. And I get a negative. And then I'll put in a value of 7. And I get a positive. So when you have decreasing on one side and increasing on the other side, that creates a minimum at the value of 6.5. So at x equals 6.5, we get a minimum So this will be the ordered pair that's closest to our 0.70. So let's go back and read the problem. Which point on the graph? So I need not just the x-coordinate, but the y-coordinate as well. So that's going to be the ordered pair 6.5. And I need the square root of 6.5. And this is the point that is closest to the 0.70 and also on the graph of y equals square root of x. Thank you for checking out my videos. Have a great day.